Today we're going to be talking about the golden ratio. Yes. Well, what the heck is the golden ratio? Basically, it's used in mathematics. It's very, very similar to the Fibonacci sequence, which will come in handy when learning how to use the golden ratio. So it's like 0, 1, 1, 2, 3, 5, 8, and it goes on and on and on. This number and this number will equal the next number. This is aesthetically pleasing to humans. It's a perfect pattern, and the golden ratio is kind of the same way. The golden ratio is also known as number 5. The Greek symbol for it is a circle with a line through it, or a lot of people have been drawing it like this online that I see. Basically the same thing though. This golden ratio, or number 5, equals A over B, which also equals A plus B over A. So if I were to draw that out for you, it would look like this. It would be a line segment, okay? And you're going to break it up into two parts, but they're not going to be even. The longer segment we'll say is A, the shorter segment is B, and this whole entire thing is going to be A plus B. And so that's how you get A over B equals A plus B over A. You take the longer segment over the shorter segment, and then you equal it to the entire line segment over the longer segment once again. So that's how you get this little equation kind of going on here. So basically this is just an overview, I would say, of what the golden ratio is. This is kind of like a shortcut to explaining what it is. It's just an irrational number. Goes on forever and ever and ever. And we know a couple things that are similar to this. We know pi, and we also know our new little friend this year, E and pi, and we know phi. They're all irrational numbers. If I can put it into the simplest terms, I would say golden ratio is just an irrational number that goes on and on and on forever without the decimal repeating. Now that we know exactly what it is, we want to know why. Why is it being used? It's not only a math thing. Artists and architects back in the day would also use it. So it's not only used for math, but also for art, which is super cool in my opinion. You might be wondering, why the heck did these artists and architects need the golden ratio? A lot of people, like artists and musicians and historians and architects, all have spent a lot of time looking over this simple ratio, the ratio of two sums, whereby their ratio is equal to the larger of the two quantities. This is where the A over B equals A plus B over A example comes into play. Leonardo da Vinci, right here, this is his painting, The Last Supper, using the golden ratio here. Also, this is Michelangelo's famous painting. These are literal masterpieces, and the golden ratio is a big part in them being made. Everyone knows this painting, and here is the example of the golden ratio being used. These red lines are displaying how it creates that perfect shape, and it's easy on the eye, which is so important and crucial to making pieces of art like this. I'm going to show you a very simple way to actually perfect the golden ratio. So this is my little square. Everyone draw a square, and we're going to give each of these sides a measurement. So we're going to do 1 for each side. And then the bottom one, just like we learned about before, how we can break up the golden ratio into a line segment, we're going to break up the bottom into that line segment right down the middle, and then the bottom is also going to be 1, but since it's split in half, it's going to be 1/2 and 1/2 now. Basically, this is where the golden ratio comes into play. We're going to take from this dot we drew right down the middle, we're going to take it and drag it up to the top right corner, and that gives us this nice right triangle we have going on here. And then we're going to take this new line that we drew, we're going to take it to the bottom here and connect it to our bottom, and look at that. Gives you a whole new shape. Your overall shape is now not a square but a rectangle. Look at this, it's our perfect shape. So This right here is where the golden ratio comes into play. You do use a little bit of trigonometry if you want to get specific with it. You find your angles, you find how long each side is, and then you basically just take the hypotenuse, you take your hypotenuse and you're going to drag it down, and it's going to give you that new length. Look at this line here now, the bottom line. Your line for your triangle, look, short line segment, long line segment. Look at this line segment right here. Doesn't matter which one is short or long, like it doesn't matter what side it's on, but if this was A and this was B, we can say that this is the short line segment, long line segment. It all adds up. Look at